Dear students, we are going to start the syllabus of BS Chemistry Semester 4. Title of the course is Inorganic Chemistry with 3 credit hours and 100 marks. In this series of lectures, we will discuss the chemistry of lanthanides. In this first lecture, we will learn about the lanthanide or lanthanide series, names, position of lanthanide in periodic table, and electronic configuration. Let us discuss one by one. The Lanthanide series, different books have different viewpoints. The class of 14 elements which follow the lanthanum element, atomic number 58 to 71, in periodic table are called lanthanide. And you know that lanthanides belong to F block elements, and these are called rare earth metals also. Another viewpoint, the lanthanide series are 15 metallic elements with atomic number 57 to 71 from lanthanum through lutetium. These elements, along with the chemical similar elements scandium and yttrium, are often collectively known as the rare earth metals. The lanthanides are shown in this small diagram with colored row. Now the names: cerium, parasodium, neodymium, promethium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. The general electronic configuration of lanthanides can be given as Ns2, then go back, N minus D, electrons 0 to 1, then go back, N minus 2F, 1 to 14, where N means 6. 6 shell is the last shell in lanthanide, because lanthanide belongs to period number 6. Position of lanthanide in periodic table. All the lanthanide have atomic weights between those of barium and hafnium. So they must be placed between these two elements, as also proved by Moseley. In some books, instead of atomic weights, here the atomic numbers are written. So you can correct, or correction can be made by yourself. Barium has exactly the same outer electronic configuration as calcium, strontium. So barium and calcium, strontium are placed together. Similarly, hafnium and zirconium are placed together in a group. Since all the lanthanides resembles one another in many aspects, so they are placed in same class, same group. These elements also resemble yttrium because of the following additional properties. A. Owing to lanthanide contraction, the ionic radii of Y plus 3 and ER plus 3 is almost same. And B. Yttrium generally occurs in nature associated with the ores of heavier lanthanides and resembles Tb3 and dy dysprosium 3 in its compounds. So they are placed together in a class or group called the lanthanide class. For the electronic configuration, we must know the Aufbau principle. The Aufbau has German roots and can be roughly translated as construct or built up. A diagram is shown here in the slide. This arrangement is done on the basis of N plus L rule or vice versa rule, which tells us that filling of electron in subshell is done from low energy to high energy, where N is principal quantum number and L is azimuthal quantum number. For example, 1s has n1, and for s l is equal to 0, for p l is equal to 1, for d l is equal to 2, for f l is equal to 3. It means the filling of electron in subshell must be done from 1s to 8s and onward, etc. Salient features: electron must be filled in subshell from low to high energy. Electron must be filled first in that subshell which has low n plus L value. If two subshell has same n plus L value, then electron must be placed in that subshell which has low n value because that has low energy. The order is given as 1s, 2s, 2p, etc. There are exceptions. In certain cases, if there is possibility of half-filled subshell, then partially filled subshell is not preferred. And similarly, when there is a possibility of completely filled subshell, then partially filled subshell is ignored or not preferred. It is due to the difference of energy gaps between certain subshells that is very low. Electronic configuration: generally, Lanthanide follow Aufbau principle, and the configuration of these elements is 6s2, 5d0 to 1, and 4f0 to 14, or 1 to 14. The lanthanide may have partially or completely filled 4f orbital, and if unpaired electrons are there, then they are paramagnetic behavior. They have paramagnetic behavior. When they have paired electron, they have diamagnetic nature. The electronic configuration on the basis of Aufbau principle can be written as, the example is given: lanthanum 1s, 2s, onward 5d0. The shells are made with different colors. The principal quantum number 1 is written separately, 2 separately, 3, 3d separately, etc. The similar is the case with other lanthanides. Actual configuration of cerium 1s2, 2s2, and the table shows the electronic configuration. This electronic configuration has certain exceptions which can be learned in a way that is called the trick for writing the electronic configuration. Inshallah, we will discuss the trick by which the electronic configuration of all lanthanides can be written in next lecture. The trick will be discussed. I repeat, the trick will be discussed in next lecture. Thank you very much.